Assalamu alaikum. So I have a difference equation here with initial conditions, and if I have initial conditions, then bilateral Z transform will of no use. So rather we have to use unilateral Z transform. Okay, so how can we do this? So if I want to transform yn, I have to write here y plus z, then 0.9. If I want to transform yn minus 1, first I have to write the initial condition y minus 1. Okay, and then z inverse y plus z. Then if I try to transform yn minus 2, just observe the pattern. First, if you have yn minus 2, so you have to write here first y minus 2, then z inverse 1 y minus 1, and then z inverse 2 y plus z. I think you got the pattern. Now if there is yn minus 3, then if you want to transform, what you have to write? First you have to write y minus 3, then z inverse 1 y minus 2, then z inverse 2 y minus 3, now all y minus 1, and then z inverse 3 y plus z. Okay, so you have to write this like this. Okay, now you have an input here x is the input. So if you transform this, you will simply get x plus z. Okay, so now we have to rearrange this equation. Let's take all the y to the left hand side. So let's first write y plus z, and then let's take this 0.9 into z inverse y plus z to the left. So minus 0.9 z inverse 1 y plus z, and then let's take 0.81 z inverse 2 y to the left hand side. So we will get like this. Okay, now let's write the input here x plus z. Let's write the input first, and then let's write all the contribution of initial conditions such as 0.91 into y minus 1, and then these are the contributions of initial condition. So minus 0.81 y minus 2, then minus 0.81 z inverse 1 y minus 1. Okay, now I have to take common y plus z. So I will get 1 minus 0.9 z inverse 1, then 0.81 z inverse 2, and here you have x plus z, and you have the initial conditions here. Write it as it is. Okay, write it as it is. Now you have to divide this thing. You have to take this thing to the right hand side. So you will get y plus z. First let's write x plus the coefficient of x plus z, which is 1 by 1 minus 0.9 z inverse 1 plus 0.81 z inverse 2, and then you have to write the initial conditions here. I mean the contribution of initial conditions. And at the denominator you have to write the same thing, 1 minus 0.9 z inverse 1 0.81 z inverse 2. Okay, now let's analyze this two term. You have two terms here, right? One is this and another is this. So the first term is called the zero state response, and the second term is called zero input response. Let's talk about the first term. Zero state response means you have to assume that all the initial conditions are 0. If what is initial conditions? Y minus 1, it is an initial condition. You have to start the time from 0, but previously, I mean y minus 1, y minus 2, these are initial conditions, should be equal to 0. Though in your question you have initial conditions both are 1, right? Y minus 1, y minus 2 both are 1, but no, now you have to assume that these two are equal to 0. And if you assume initial conditions are 0, you see y minus 1, y minus 2, y minus 1, this term will be equal to 0, right? Because this will become 0, then this and this term will become 0, all the terms will become 0. So if initial conditions are 0, you only get the first term, so y will be equal to only the first term. So this is called the zero state response. Okay, now let's talk about zero input response. By the name you understand that you have to take input is equal to 0. If input 0, its transform will also equal to 0. That means the first term will be equal to 0, right? As you have the x plus z here. That means if input is 0, y will be only the second term. That means this is the zero input response. Okay, so now we have to convert this zero state response into n domain, then zero state input response, then zero state response to the, I mean we have to convert these two terms in n domain, then we have to just sum that two terms and we will get yn. So let's first work with the zero state response. So yzs, it is the first term. Okay, the first term is 1 minus 0.9 z inverse 1 plus 0.81 z inverse 2 x plus z. Okay, now I need to convert this denominator. And how can I do this? First I have to assume that 1 minus 0.9 z inverse 1 plus 0.81 z inverse 2 is equal to 0. And if I assume this, I will get a z inverse, two values of z inverse 1. If you calculate, you will get two values here. One is 0.9 e to the power j pi by 3, and you will see that another is the conjugate of p1. Okay, and that means you can write these two things like this: 1 minus p1 z inverse 1. Take time and you will see that you can divide this denominator into two multipliers. Okay, now what about x plus z? If you see the question, this is unit step response, right? So unit step response means the xn is simply un, and we all know the z transform or unilateral z transform both are same, which is equal to 1 by 1 minus z inverse 1. So let's write this x 1 by 1 minus z inverse 1 here. So let's write this thing 1 by 1 minus z inverse 1. Okay, now we have to do a partial fraction here. That means I have to write 1 minus 1 by p z inverse 1 is a1, then a2 1 minus p2 z inverse 1. That means now I have to find the value of a1, a2 and a3, right? So you can find a1, a2, a3 with a lot of techniques, but I have a shortcut here how to find a1, a2 and a3. Let me tell the shortcut here. First, let's try to find a1. Okay, so how can I do this? At the value of a1, you have 1 minus p1 z inverse 1, 1 minus p1 z inverse 1, and take this equal to 0, and if you do so, you will get the value z inverse 1 is equal to 1 by p1. So now you have to put this value here and also here, but don't put this value here, okay, because if you do this, then 1 minus p1 z inverse 1 is 0, so this term will become 0 and you will get an undefined result. So don't put this here, you have to put this here and here. So if you do this, 1 minus p2 is the second multiplier and 1 by p1, and then put this here, so you will get 1 by p1. Okay, and if you do this, actually this is the value of a1, this is the value of a1, is the shortcut technique, and if you do this, you will get a1 is equal to 0.0496 minus j 0.542. okay, you can do this to find a2. Let me tell that also. If you want to find a2, then what you will do, you will see that what is below a2, you have 1 minus p2 z inverse 1 minus p2 z inverse 1, and take this equal to 0, so you will get z inverse 1 is equal to 1 by p2. So now you have to put this value here and here, and you see you don't have to put this value here, because if you put this value here, then 1 minus p2 z inverse 1 is equal to 0, this term will be undefined, so don't put this here. So if you put that value at the first multiplier, 1 minus p1 1 by p2, then if you do this, you will get a2. okay, so a2 is 0.0496 plus j 0.542. that means these two are conjugate, right? You see a1 and a2 are conjugate to each other, and so I easily can get the value of a1, which is 0.0496 plus minus j 0.542, and a2 is equal to, and a2 is equal to 0.0496 plus j 0.542. okay, let's assume that a1 is equal to a and a2 is the conjugate, right? So this is simply is equal to a conjugate, and we have to find, and we can write a is the magnitude of a and the phase e to the power j alpha. So if I calculate a, the magnitude of a from here, simply I will get what I will get, let me calculate it. I will get 0.544 and e to the power j, you can take it as radian, but I am taking this in degree. okay, so 5.2 degree. okay, now what? okay, now let's take p1. So what was our p1? p1 was 0.9 e to the power j pi by 3, 0.9 e to the power j. I think you are wondering why I am doing this. You will understand it very soon. So you see these two p1 and p2, these are poles, so these two poles are also conjugate to each other. So let's take it r, So this will be R conjugate. So what is R? R is the magnitude of R and the phase of R. So the magnitude of R is 0.9 and beta is simply is equal to pi by 3. We need this. We will need these two things. Okay, let me draw this in different color. I will need this. Okay, so now this is YZS, right? So this is YZS. So and you have two terms here. So if you want to convert this, if you want to do inverse Z transform, and if you want to convert this to n domain, so what you have to do, let me write that thing again. YZS, here you have A1 1 minus P1 Z inverse 1, and then A2 1 minus P2 Z inverse 1. I have another term here, let me write it later. So if I want to convert it, and if I want to know this thing, so what can I do? I have a direct formula here, which is 2 the magnitude of A, the magnitude of R. What is R? You see, I have choose one pole is equal to R, so the magnitude of R, then cos beta n plus alpha. So this is my formula, where A is equal to 0. Magnitude of A is 0.544, R is 0.9. Oh, let's take it first bracket. Then beta is equal to pi by 3, right? And alpha is equal to minus 5.2 degree. Don't be confused that this is radian pi by 3 and this is degree. It's okay, no problem. And then UN. Okay, now let's, it's a direct formula. Now we can work with the third term, which is A3 1 minus Z inverse 1. Okay, and if you do the similar thing, shortcut for A1, shortcut for A2, if you do the similar thing to find the find A3, you will see that A3 is simply equal to 1.099, and if you try to convert this thing, you will get 1.099 UN. So 1.099 UN, and this is my zero state solution. Okay, so this is my zero state response. Now we need to find zero input response. Okay, so let's now try to find zero input response. So now I have to ZI. So now I have to find the zero input response in Z domain. And what was that? This thing, right? So let me copy this thing, and then let me paste here. Okay, so this is okay, so this is my zero input response. And can you remember that what was our initial conditions was? Both the initial conditions in the question was 1. In the question, both the initial conditions was 1. So if I calculate it, I will get 0.09, then 0.81 Z inverse 1, and at the denominator you can write 1 minus p1 z inverse 1, 1 minus p2 z inverse 1, where p1 is 0.9 e to the power j pi by 3, p2 is equal to 0.9 e to the power minus j pi by 3. And again you have to do a partial fraction here. One is a1 1 minus p1 z inverse 1, another is a2 1 minus p2 z inverse 1. So if you apply the same shortcut, same shortcut here, then you will get 1 minus p1 z inverse 1, and the a1 is 0.045. Wait, it's a1 prime and a2 prime, as we have used a1 and a2 previously. So this is a1 prime, which is 0. No, we have to find this. Okay, so let's find this using shortcut. So let's use the shortcut here. Okay, so now we have to we want to find a1 prime. So 1 minus p1 z inverse 1 have to set 0, then z inverse 1 is equal to 1 by p1. So now we have to put this value of z1 inverse here and here. So what I will get, let me calculate it. Okay, so I get, after putting the value 0.495 and the 495 e to the power j 1.479. okay, 1.479. okay, then I will, if I use the shortcut again for a2 prime, you will see that a2 prime is simply the conjugate of a1 prime. Okay, so if you have seen this previously, that where a1, see, a1 and a2 both are each other's conjugate. Similarly, you will see that a1 prime and a2 prime are both each other's conjugate. So if you find one, you will automatically find the other. Okay, so now what was our shortcut? Our shortcut was our formula was 2, then r to the power n, then a, then cos beta n plus alpha, right? So what is r? Let's take p1 is equal to 0.9 e to the power j pi by 3. It is r, and r is equal to the magnitude of r, and it's j beta. Okay, so let's write r is equal to 0.9 and beta is equal to pi by 3. Then we know that a is a e to the power j alpha, right? And from here it's actually a prime. So a prime is 0.495 e to the power j 1.479. oh, it's in radian. Okay, I have set my calculator in radian mode, but it's your choice. You can take it in radian, you can take it in degree, it's your choice. So let's write here 0.495, then write here 1.479. so this is my zero input response in n domain. Okay, so now I have to find the total response yn. So what I have to do, I have to simply sum the zero input response in n domain and zero state response in n domain. So my zero input response is this, and what is my zero state response? I have found this. So this is my zero state response. Okay, So thus you, and this is the video to solve any difference equation using if you have initial conditions. Thank you.